You've seen that increasing the detection score threshold makes the detector pickier about what it detects. The detected objects are more accurate, but you might miss some. Lowering the score threshold causes the detector to detect objects more easily. You're more likely to find all the objects, but you're also more likely to get some false positives. Two metrics for evaluating this trade-off are precision and recall. Precision measures how accurate your detections are. For this image and low score threshold, 4 out of 5 detections are correct, so the precision is 0.8. Recall measures the fraction of objects, here turtles, that you actually found. And the recall for this score threshold is 1, because you found all 4 turtles. With the higher score threshold, all 3 detections are correct, so the precision is 1. But we missed one, so the recall is 0.75. Now, here we looked at the precision and recall for a single image. But it's more common to evaluate how a detector performs on a class using all of the test images. How do you use these metrics on your test set to evaluate your model and choose an appropriate score threshold? You first need to run your detector with a low detection score threshold on your test images to get a list of all the detections and their corresponding scores. A common way to analyze the results is to plot precision and recall as they change with the detection score threshold. Here we have a plot of precision versus score. Each point corresponds to a detection with a score. This point represents a detection with a score of 0.2. So if you set the detector score threshold to 0.2, these detections are included in your results, and your precision is 0.6. At 0.7, your precision will be about 0.89. And at 0.8 or above, the precision is 1, meaning your detections are all correct. Perfect precision sounds great, but what will that do to the recall? Again, each point in the recall versus score plot corresponds to a detection with a confidence score. Recall decreases with the score, since a pickier detector detects fewer objects. If we go for perfect precision and use a detection score threshold of 0.8, recall drops to about 0.53. So, how can we get a good recall? You can visualize precision and recall together with the precision recall curve, which shows how precision and recall change as you decrease your threshold, and also helps you compare performance between classes. By convention, the plot starts at 0, 1. There is 1 point for each detection score. The highest detection score is 0.99, and it has recall and precision of 0.07 and 1 respectively. The next score is 0.98, and it has recall and precision of 0.13 and 1 respectively. You continue plotting precision versus recall for decreasing detection thresholds. This may be easier to understand by viewing a list of detections. All of the detections with a score of 0.8 or higher are true positives, which, as we saw, makes for perfect precision. But 0.7, the detection score threshold is low enough to include a false positive in the results. Precision goes down and recall stays the same. Then we have 4 correct detections, so precision and recall go up, followed by a bunch of incorrect detections, causing precision to drop with no gain in recall, and a correct detection, and a false detection. The 2 natural choices for a detection cutoff stand out as elbows in the precision recall curve, 0.8 and 0.4. Let's see how we did with the American Sign Language example.